Now we'll summarize what we have learned so far, starting from the white noise. As we have seen that white noise has equal distribution of power across its spectrum. It has no preference for any particular specific frequency. So it has a constant power spectrum density, and that's happening because beta is 0. And then we move over to pink noise, where beta is 1, which results in 1 by f frequency spectrum. And as we see that pink noise has higher power at lower frequencies and a lower power at higher frequencies. The roll-off is gradual in nature. It is at 3 dB per decade. Then we have a brown noise where beta is 2, and it is exhibiting a power spectrum density of 1 divided by f raised to the power 2. Here we see that the high frequencies, they almost have no power, and most of the power is concentrated in the lower frequencies. Also, the rollover is much steeper. This slope is much steeper in comparison to pink noise. In fact, this is at 6 dB per decade roll-off. And then we have the other end of the spectrum, which is blue noise. So here, actually, you see these are all they acting as noises coming out of low-pass filter. And here it is the exact opposite. Here we see that blue noise is proportional to the frequencies of the noise. And at low frequencies, the energy is quite low. The power in the noise spectrum is low. And at higher frequencies, we have more power. But the roll-off is 3 dB per decade. We don't have an absolute cutoff at low frequencies. In comparison, violet noise, which we have not simulated in Python, we have just as an example, I'm just showing it on the slide here. Here we realize that there is zero power at the lower end of the spectrum. The lower frequencies have almost got cut off, and most of the power is concentrated at the higher frequencies. So essentially, violet is the exact opposite of brown, and blue is the exact opposite of pink noise. So it was very important for us to understand how the noise behaves, and in the next tutorial series, we will devise signal processing algorithms to filter these kind of noises from our system. I hope you learnt a lot. Thank you so much.